Lesson 8.1 deals with some function operations. Some of these are going to be fairly easy and you'll have heard them or seen them before. The last one is probably going to be new to us and a helpful operation for functions. So what we're going to do is we're just going to compare kind of two ideas here. Adding two functions and then inserting a value. So that's one idea we're going to deal with. And we're going to say, so we're adding the two functions first and then inserting a value, is the same as inserting the value first into each function and then adding them together. So adding two functions first and then inserting the value is the same as inserting the value and then adding the two functions. And actually down here, I kind of have this in the opposite order. So over here is adding my two functions, and then over here is putting the value in. So it says, let f of x equal 3x minus 1. So I have this little, I call it a function machine. What this does is if I drop a number in here, if I drop a 7 in here, it puts it in, it multiplies it times 3, so 7 is kind of like our x, it multiplies it by 3, which will be 21, then subtracts 1, which will be 20. So if I drop a 7 in there, out will come a 20. If we drop a negative 15 in there, 3 times negative 15 is negative 45 minus 1, out comes a negative 46. So something like that. G of x is x squared minus 4, so if I put a 2 in here, it would be 2 squared, which is 4, minus 4 times 2, which is 8, so 4 minus 8, out would come a negative 4. So that's the idea of these function machines. They perform something to whatever number is dropped in there. Well, it says find f of 3 plus g of 3, and then find f plus g of 3. So f of 3 plus g of 3, that's kind of saying, let's put 3 in here. We get a 3 times 3 is 9 minus 1 is 8. Put a 3 in here. 3 squared is 9. Minus 4 times 3 is 12, so out comes a negative 3. And we want to add those two answers, so 8 plus negative 3 is 5. The other thing is saying plug 3 into f plus g of 3. So it's saying actually add our two functions together. So I have this smaller here. So we're going to add f of x, which is 3x minus 1, plus g of x, x squared minus 4x. So we're going to look for like terms. We have an x squared here. So we have an x squared here. We have a 3x minus 4x, so that's where the negative x comes from, and then negative 1, just a negative 1, so minus 1. And so this is the two functions added together, and now we're going to drop in a 3 in here. So we put a 3 in here, we get 3 squared, which is 9, minus 3, minus 1, which 9 minus 3 is 6 minus 1 is also 5. And that's what it says would happen, that we should get the same answer. If we look at this algebraically and you don't have these little function machines here, we could look at this and say f of 3 plus g of 3. F of 3 just means we put 3 in here, so this is 3 times 3, that's this 3 here, minus 1. And then plus g of 3, that's 3 squared minus 4 times 3. And we get 9 minus 1. I know this is written a little funny looking here. So 9 minus 1 is 8, plus 9 minus 12. That's 17 minus 12 is 5. So if you didn't have these machines to like drop it in here, you can just plug it into the expression and add them together. So that's addition, and it's going to be similar for all of these, so it's going to kind of seem a little old after we look through these, but this time subtracting two functions and then inserting a value is the same as inserting the value into the functions first and then subtracting the answer. So f minus g of x is the same as doing f of x minus g of x. Here, asking the same idea, except this time it's subtraction. So let's just look at kind of the algebra way again. So we want to do f of 3 minus g of 3. So f of 3, that's where we put 3x. Well, 3, sorry, and our x is a 3. So 3 times 3 minus 1. And then we're going to subtract g of 3. So putting 3 in for g. I'm going to put parentheses here because we're going to subtract this whole value. And this is going to be 3 squared minus 4 times 3. So we have 9 minus 1 is 8, minus 9 minus 12 is negative 3. So this is 8 minus negative 3, which is 11. So over here, we could drop a 3 in here. 9 minus 1 is 8. We could drop a 3 in here. We've done both these already. This is 9 minus 12, which is negative 3. And we want to subtract them though this time. And then we could drop a 3 in here. Here we showed the subtraction. So this negative ends up getting distributed. So we have negative x squared. That's here. And then we have 3x minus negative 4x. Well, minus a negative is 7x. And then we have the minus 1. Drop a 3 in here. We get negative 3 squared plus 7 times 3 minus 1. This is negative 9 because we square the 3 first, then put the negative. So negative 9 plus 21 minus 1, negative 9, and negative 1 is 10. 21 minus 10 is 11. So same idea. Multiplying, it's going to be the same idea. We actually already know what all these are equal to. If we do f of 3 here, f of 3 was 9 minus 1, which was 8. G of 3 is 3 squared, which is 9, minus 4 times 3, which is 12, which is negative 3. So f of 3 times g of 3 is going to equal 8 times negative 3, which is negative 24. And then here we have them multiplied together. Use FOIL, multiply it out, get like terms, then you can drop a 3 in here. This is 3 times 3 cubed minus 13 times 3 squared plus 4 times 3. This is 81 minus 13 times 9 plus 12. 13 times 9 is 117, so we have 81 minus 117 plus 12. 81 and 12 is 93, and negative 117 plus 93 is negative 24, so we get the same thing. Moving on to division. We know f of 3 is 8, and g of 3 is negative 3 from the ones we did before. And then here we have the division, so it's f of x over g of x. So we can plug a 3 in here, and we get 9 over 8 over negative 3. And that's what we get here if we do them separately. 8, we found this one. We found this one's negative 3, so 8 over negative 3. They are the same thing. Now our last one is the composition or composing of functions. That's when you put one function within another function. And this little symbol here shows that. So this is the composition or composing, putting two functions together. And so what it means here, f composed with g of x means that you take the g function and put it into the f function. So this means f composed with g. That means g is put inside of it. And if you write it in the other way, g composed with f, that means you put the f function inside the g function. That's what this is showing here. F composed with g of x is the f function with the g function inside it. And so composing two functions involve putting x into one function, so taking some value, x, maybe 7, maybe negative 9. Taking it, put it in one function, taking that answer and putting it right into the next function. This is actually the same. Instead of just putting an individual one in, you could put the entire function into the other function and then plug in a value. So let's look at this here. We want to find f composed with g or this. So this here, order of operations tells us we do what's inside first. So we're going to drop a 3 into our g function. Well, we drop in a 3. We get 9 minus 12, which is negative 3. And that negative 3 comes out of g, drops right into f. So the answer from that one drops into our other function. So this is 3 times negative 3 minus 1. So that's negative 9 minus 1 is negative 10. Now on this one, we're going to take the g function and put it into the f function. That's what f composed with g of 3 is. So we're taking this function, putting it in for x here. And so we have 3 times x squared minus 4x minus 1. So we can distribute. This is going to be 3x squared minus 12x and then minus 1. And we're going to drop a 3 in here. So this is 3 times 3 squared minus 12 times 3 minus 1. So this is 3 times 9, which is 27. So we have 27 minus 36 minus 1. So we have these two negatives together make negative 37. 27 minus 37 is negative 10. And we get the same answer. So this last example that we're going to do here just does more the algebra of it. We're going to find two compositions here. We have h of x equals 2x squared and m of x equals 3x minus 1. Find h composed with m of x and then m composed with h of x. So we're actually switching them. So we're going to find both of those. So we're going to start with h composed with m of x. And so what this means, I'm going to write out a step here. This means I'm going to put the m of x function into my h function. So I'm going to put the m function into my h function. So this is going to be 2 times 3x minus 1 squared. Because I put this value in for x. And we can simplify this. 3x minus 1 squared is multiplied by itself. So we have 2. We'll leave that and we'll just multiply at the end. So multiplying this out, we get 9x squared minus 3x minus another 3x plus 1. We got a couple like terms here, so that's a negative 6. I'll just change that to negative 6x. And now we can multiply by 2, and we have 18x squared. 2 times negative 6 is negative 12x, and 2 times 1 is 2. So this value right here is h composed with m of x. And now we want to do the other way around. We want to do m composed with h of x. And you might think, well, maybe they're the same thing. If they're the same, they would have the commutative property. So let's see if they do. So this means I want to put the h function into the m function. So I'm going to take my h function this time, so we'll do this circled. I'm going to take my h function and put it in for x into the m function. So I'm going to put 2x squared in there. So I'm going to have 3 times x, so I'm putting 2x squared in there. I'm putting the h function in there. So 3 times x minus 1. And we'll quickly see, so this is 6x squared minus 1, and that's all we have to do there. So we can see what m composed with h is. And we also notice that these two are not the same. So composition does not have the commutative property. So we looked at addition of functions, subtraction, multiplication, division, and composition of functions.